Everyone. It's Sunday, November the 5th, 2017, about 10:30 a.m. Eastern Standard Time, and this is DelrayVAweather.com. This video is going to cover the logic I used to do the snow prediction range for Reagan National Airport for the winter of 2017-18. And just to go through some of the logic that I did. Okay, what you see up on the screen is a chart I did a couple of years ago comparing various types of winters, whether it was a El Nino winter, a La Nina winter, a neutral winter, or what I refer to as a non-El Nino winter. Usually that includes a sum of both neutral and La Nina. And if you can see from the graph, this is the probability of having greater than 4 inches of snow at Reagan National Airport. If we look at which have the peak probabilities, you'll see that in the La Nina winter, the peak occurs in January at 84.8%. where in an El Nino winter, it occurs in February at 98.7%. So in the type of winter we're going to have this year is a La Nina winter, about almost 70% probability of a La Nina. We can expect that the bulk of our snow is going to occur in January as opposed to in February. And if you think back, the last El Nino actually occurred towards the end of January, but it was close enough that supported the shift that El Nino shifts it more to February compared to a La Nina. Will we have a white Christmas? Well, if you look at this graph, this part of the graph down here for December, the highest probability of a white Christmas occurs in an El Nino winter, not a La Nina. So consequently, the chance of a white Christmas is pretty low this year. Okay, let's take a look at this next graph. This shows the average inches of snow by month for the different types of winters. And if you look at the average inches of snow for February for a El Nino is 11.2. where the average for a La Nina is in January, the peak, and it's 7.2. So again, it shows that the probability of snow in a La Nina shifts more into January rather than into February. Okay, now we have basically two types of winters, El Nino or La Nina, but there's some other teleconnected indices in various parts of the world that do seem to have an effect on the Washington metro winter. Those two indices, from my research, are the PNA, Pacific North American Index, and the NAO, which is the North Atlantic Oscillation. From my research, actually, PNA is the most influential in the DC area. Many researchers look a lot at the NAO to find out how snowy it's going to be on the East Coast. But my research, at least for Reagan National Airport, show the PNA is the most important. Okay, so basically there are multiple combinations you can do with these indices and the types of winters. And this graph shows the result of doing the analysis for those different permutations. The first line here shows for just looking at a La Nina only, not paying attention to the NAO or PNA. The average for that winter is 10.78. If you look at La Nina winters in which we had a negative NAO at the end of October, and all these values, I'm only looking at the sign of the NAO and the PNA at the end of October. It has nothing to do with their magnitude or how they changed in January or February or any other month. It's only looking at where they are in October, and because October seems to correlate pretty well with what the resulting snowfall is for the winter, and it's probably because October, by the end of October, the weather conditions in the northern hemisphere has pretty much shifted in the direction that they'll ultimately go. So with that in mind, La Nina with a minus NAO, independent of what the PNA is, comes in at 10.18 inches. A La Nina with a plus NAO comes in at 11.1 inches. Then looking only at the PNA, ignoring the NAO, we have the La Nina winters with a minus PNA is 10.53 inches. Those La Nina winters with plus PNA at the end of October comes in at 10.92 inches. And then we look at the combinations of those two indices with La Nina. So basically, if you have two indices, that gives you four possible combinations. With a La Nina winter that has a plus PNA and a minus NAO, we have 10.17 inches for the season. La Nina winter with a plus PNA plus NAO is 11.24 inches. A La Nina with a minus PNA and a plus NAO comes in at 9.06 inches. This is the combination that we're dealing with this winter. So this is the real focus of the rest of the video. And finally, there's one other permutation. There's a La Nina with a minus PNA and a minus NAO. Shows 14.2 inches, which looks like it's the highest amount for a La Nina winter. But this only contains about 2 years, 2 La Nina years since 1954. So it is, I think, a little suspect. It really doesn't have a whole lot of years to judge this by. And so I sort of think that this is, not really relevant. Particularly this year, we're only dealing with this, so we can sort of ignore this. But that's just a caveat for this. This seems to show this is the snowiest La Nina combination, but it may not be. Okay, so let's go to this next chart. Okay, what I did, I wanted to double check to see if the data sets follow a normal distribution. And if you look at only La Nina years, not paying attention to PNA or NAO, from 1954 to 2016, there were 21 years that were La Nina winters. That average, if you average the amount of snow in those 21 years, the average comes out to 10.8 inches, and the median comes out at 10.8 also. Now, when the average and the median are very close together, or identical in this case, that suggests a normal distribution. There's some other analyses that I've done to make sure there was no skew in the data, and there wasn't. So this is definitely suggestive that we have a normal distribution. We can use the statistical tools to analyze the data. Also, if we choose a smaller range, which often the climatologists do for this area of 1981 to 2016, there's 13 La Nina winters that fit that criteria. They average again at 10.0 and a median of 9.4. A 0.6 of an inch difference is also suggestive of a normal distribution. If you look at what the average for this entire range, 54 to 2016, both El Nino and La Nina and neutral and everything else, it comes in at 16.4. Doing the same for the shorter range of 1981 to 2016, it's 15.1. And that's the figure that I usually use as the average snowfall at Reagan National. You can see that the average of a La Nina winter in both of these columns is substantially less than the average if you look at all the years, regardless of whether El Nino, La Nina, neutral, whatever. Okay. So that does suggest that in La Nina winters, we get less snow at Reagan National. Okay, this then also looks at La Nina winters, but only those winters that have a minus PNA at the end of October. And from 1954 to 2016, there were only 7 La Nina winters that fit that additional criteria of a minus PNA. If you average up those 7, but basically you're dropping 1 because of the winter of 2016 is an outlier. The average La Nina is 0.5 inches. Again, it's similar to what we had with the not ignoring the PNA completely. Okay, and that standard deviation happens to be a 5.2 inches. Okay, looking at the combination of the minus PNA plus NAO in La Nina winters, that drops the number of winters that meet the criteria to 5. As you can see, out of these 5, 4 of the 5 are substantially less than the average. The average is the red line. Only 1 is above the red line. So that says that 80% of the members are below average snowfall. Okay, so doing the analysis of those 5 since 1954, the average in the La Nina years is 9.1. Median in La Nina years is 8.6. It is close enough to indicate a normal distribution, and this shows the average again for the entire 54 through 2016 of 16.4. Okay. Okay, so we're going to get to the prediction now. Okay, with PNA, minus PNA alone, the range would come out to be 5.3 to 15.7 inches at Reagan National with a 68% probability. Basically, that is 1 standard deviation plus or minus around the average for that period. With minus PNA plus NAO, the additional criteria of NAO, the range comes out to be 3.8 to 14.4, 68% probability of that falling within that range. Again, that's plus or minus 1 standard deviation around the average of this combination. Okay, so what I did to come out with the range, my final range of 3.8 to 15.7, is I blended the two. I took the highest for the PNA alone and the lowest for the PNA plus NAO. If you plug that range into the probability formula, it comes out to be approximately a 73% probability that the final snowfall at the Reagan National will fall within that range. Okay, so this only really applies to Reagan National Airport's official snow totals at the end of the year, because that's the data set I used. I didn't, there's no data set for Alexandria or Arlington, but there is a pretty good data set for Washington Reagan National Airport going back to 1954. But because Alexandria and Arlington are so close to Reagan National, it probably would be correct to use this range for at least Arlington and Alexandria, and maybe some of eastern Fairfax County. So, keep that in mind as well. Okay, so what will winter be like? I think everything that I showed you shows that it average to below average precipitation. It's pretty going to be a dry winter, more dry than normal, or at least just a normal amount of precipitation. It should have average to above average temperature, and that's partly driven by the minus PNA here, in my opinion. Okay, is minus PNA tends to have a little warmer temperatures than a plus PNA. Okay, average to below average snow. This is the analysis we've shown in the video. It's pretty clear this is going to be uh, probably no more than average, but more likely substantially less than average. Okay, other observations that I think need to be looked at. About 2 out of every 10 Nina winters, snow will be less than my lower boundary or greater than my upper boundary. And that's just the nature of the statistics. It's going to be, an error about probably 20, maybe 20% chance of busting the range. So you snow lovers, you don't lose all hope, but it's a pretty low probability. Okay, 1 out of 10 Nina winters will have a disruptive snowfall. That disruptive I define as greater than 10 inches. And usually that happens the first half of January, somewhere between January 1st and the 15th. So keep that in mind. If you have travel plans early in January, that has the highest chance between those dates of being disrupted if you're traveling to or from the DC area. Okay, the Northeast, including the Mid-Atlantic, should have between 1 to 2 nor'easters. I think that these nor'easters are going to pretty much follow the track that some of the hurricanes took, is that they're far enough offshore where they're not going to impact the DC metro area. So, the snow amounts may be a bit higher the further north you go. The data analysis I do is only for Reagan National Airport, but I think it's a good likelihood that we're going to have maybe 1 or 2 nor'easters this winter, probably no more than 2. Okay, so that wraps up the logic behind the prediction of between 3.8 inches to 15.7 inches as a total amount in this area. And if you have any questions, just give me a tweet. It's at Pat Penn, that's PATPEND, and I'll try and answer them. Thanks a lot.